Good day, everyone. I'm glad to welcome you once again to this edition of the Blaze Cloud webinar series. As some of you might have already known, this is a series of webinars we've been organizing to enlighten ourselves better on ways to improve the way we work and deliver buildings in our industry. In the previous webinars, we've had quite a number of interesting sessions. We had sessions from planning, we've had sessions from local systems together with 360 virtual tours. We've had so many other webinars featuring 3D and collaborative ways of working and delivering buildings in our industry. So in this edition, we're talking about smart buildings, and we also go beyond that to talk about why BIM alone cannot solve all the problems of the construction industry. Of course, BIM stands for Building Information Modeling. So I'll start by telling you a bit about myself. So I'm an architect by profession. When I say I'm an architect by profession, that means I've gone beyond architecture to engage myself with some other things, especially as regards technology. When I was in the university during my MSc, I started to research into smart building technology. So when I got to my final year project back in AECO, I researched on smart building technology. So that was when my interest and my research on this topic started. That was way back as 2014. I finished my program back in 2015. But then when I finished my education, when I finished my school, my BSc, MSc, NYC, and all that, I chose to work for a home automation company called However Smart Homes. So I worked in However Smart Homes for well over 2 years in the capacity of a system designer. So I was charged with designing different technology systems. I worked in However Smart Homes between 2016 all the way to 2018. Towards the end of 2018, that was when I left. And during that period, I was able to sit for a certification exam at CTS offered by the visual industry at Visa. So today I'm a certified technology specialist. But when I left However Smart Homes, that was when I began to focus more on Blaze. So Blaze is a BIM consultancy and IT integrations outfit that is based in Nigeria. And we offer quite a number of different services, especially as regards how to help AEC, architecture and construction firms improve their workflows and processes. So most of the time, I find myself engaging in quite a number of projects, mostly as a consultant in different capacities. Sometimes I can consult as an architect, sometimes as a system designer, sometimes as an engineer. So I'm actually an Autodesk certified professional for Revit architecture. I'm also an Autodesk certified instructor. And as far back as 2018, I began to write a number of articles. So to date, I've written over 17 different articles. And last year, I was able to publish a book titled Essentials of Smart Building Technology, which is currently available on Amazon and so many other ebook platforms. You can also visit our website, blazethread.com/resources, and you'll find most of the articles I've written there freely available. And also run a Medium publication, medium.com/Blaze Academy. You can also see most of my articles as well as the ones written by so many other people. So last but not the least, I'm also a founding advocate of BIM Africa, which is a Pan-African non-profit organization that is charged with BIM awareness and implementation across Africa. So that's quite enough about me. So in this particular presentation, this is what I'll be running you through. I'll start by looking at the history of smart building technology and then offer some foundational framework for referencing smart building technology. So when we talk about smart buildings, what do you reference? What are the tenets for referencing smart building technology? And once I lay out foundation, I'll now begin to look at the various technology systems that can be integrated into smart buildings. So look at so many technology systems, and we also wrap that up by looking at the system of aesthetic presentation when it comes to smart buildings. So this is mostly going to be looking at it from an architectural perspective to find out if smart buildings have their own architectural movements, as against so many other architectural movements that have taken place over time in history. And then after that, we'll also look at some not so distant innovations that are possible leveraging this smart building technology. Some of them might come as an opposition to the norm today in our industry. So, but we'll look at ways we can leverage smart building technology to improve the way we design and deliver buildings, and also the way the building themselves actually operate when they've been delivered. And then after that, we'll now begin to look at building information modeling. And we'll see that this serves mostly as a delivery vehicle. I'm sure that some of you, when you saw the flyer for this webinar, you thought I was perhaps pushing against BIM, but because of this webinar, we actually see that BIM is a delivery vehicle for making smart building technology a success. And one of the ways to do that is to leverage what is called the integrated project delivery, which is a contract method. So after looking at BIM as a delivery vehicle, we now look at the facility management stage of smart buildings. And one of the important concepts to look at here is the concept of digital twin. And we'll see how that's, whether it's a reality today or it's still a theoretical research. We'll see how it can help us to maximize these benefits of smart building technology. And then last but not least, we also look at the utility values of smart building technology. So here we begin to realize that smart building technology is not really luxury per se, but it's more of a utilitarian, it has more of the utilitarian benefits. And then we'll look at Africa as a case in point. With that, will drive the point home. So most of the time, I like to start my presentation with a story. So I would like to lay some historic background as regards smart building technology. So back in 1984, the New York Times article described real estate developers that are creating a new generation of buildings that almost think for themselves. They call these buildings intelligent buildings. Such buildings are defined as a marriage of two technologies, which is the old-fashioned building with management and telecom. So back in the early 80s, the telecommunication industry was undergoing the relegation, and that ushered in a lot of products and services into the industry. And also at the same time, that was when the PC began to come into the scene. So because of these lots of emergence that are coming in, real estate developers at that time began to look at ways to leverage this technology to improve the value of their property. So what they basically did then was they leased these are telecom solutions and products in bulk, and they now leased it out to their tenants, which is referred then as the shared tenant services. So, but over time, these people, because their original intention was just to increase the value of their properties, they realized that it wasn't so profitable for them. And not just that, they were also not tech savvy enough to manage these telecom products and services. So eventually they had to abandon most of these experiments. But that was the first time in history when we realized that okay, we'll actually leverage technology to improve our buildings. But this was mostly viewed as an add-on to the original building. But then in the next decade, there are so many other technology advancements that began to come into the scene. We began to see such things as home automation, building automation, using digital direct controllers, such things as IP surveillance cameras, telephone system, access control system, security system, and so many other technology systems began to come into the scene. But despite that, technology was still viewed as an afterthought rather than an integral part of the building design. So at this, well, of course, we're talking about a decade later, which is in the 90s, technology systems are beginning to come into the scene, but they were still viewed as an afterthought. They were not thought as an integral part of the building design and delivery process, which is quite different when you compare our industry with other industries. For example, if you look at the telecom industry or you look at the automobile industry, see that, or even the PC industry, you see that when they're talking about technology integration, everything was more holistic. So these are one of the things we'll be looking at in this particular presentation on ways to actually marry technology with the building itself and also the way we design and deliver this building. So having laid down that foundation, that historic background, what then is smart building? So according to James Napoli in the book he wrote, which is a smart system for architects, owners, and builders, he defines smart building technology as the process of conceiving, designing, constructing, commissioning, and operating buildings, leveraging technology to optimize the goals and objectives of the built environment. So when you look at this definition, two things will catch your attention. First of all is that smart building technology actually spans the entire life cycle of a building, starting from the conceptual stage all the way to the operations and maintenance phase, unlike just looking at it as an add-on that you purchase after the building has been designed. That's one. Then the second one is that the end goal of this is to optimize the goals and objectives of the built environment. So that tells us that smart building technology on its own is not an end, rather it is a means to an end, and that end is to improve our environment and also to improve the lifestyle of the end user. So from this definition, I realize that smart building technology is quite different from what some people look at it today. Some people look at it as just a way to make our buildings look luxurious or just to improve the value of their properties, but it's actually an integral part of the design and delivery process, and it's also meant to help the end users improve their lifestyle. So having laid down that background and definition, What then are the tenets for referencing smart building technology? When I talk about tenets, I'm talking about what and what do you refer to, what and what do you reference when you talk about smart building technology. So I've been able to break this down into 5 major foundational framework. And the first one is what is referred to as the OSI reference model. OSI stands for Open Systems Interconnection, and this is offered by the ISO, which is the International Standardization Organization. So according to ISO, they're able to break down the components that are found in a typical network stack into 7 major layers. For me to even drive that point, I would like to use a basic illustration. So imagine that you visit a commercial cinema today. Of course, because of the pandemic, we might not be able to have such experiences at the moment, but let's even assume that everything is in order and you visit a commercial cinema. When you come into the cinema, of course, what you get interactive is a big screen that displays motion pictures, right? But behind that big screen and the motion picture you are seeing, a lot of connections have been put in place. I mean, behind that the display you see, there are some devices that transfer the signal that you see into the motion pictures. There are some devices that are controlling how the signals are being transported. There are some devices that the backend engineers actually use to execute commands, choose which movie to show and whatnot. There are so many devices. So in the information in the IT industry, it was a bit hard to classify most of these devices. That was what brought about the OSI reference model. And then ISO came up with 7 major layers, which has to do with the physical layer, the data link layer, the network layer, the transport layer, the session layer, the presentation layer, and the application layer. That's quite a lot of layers, but I'd like to reference 3 major layers out of these 7. The first one is the application layer. So when you walk into a smartphone, for example, today, and you find a touch screen on the wall, or you have an artificial intelligence program with which you execute command, or whatever interface it is that you use to communicate with this building, as long as you have interface with these particular devices, those are most likely an application level device. But then when you execute this command needs to travel through something. And then something has to control how that information travels to the final device. So most of the time, this is where you begin to find the network and the transport layer. So the network and transport layers devices are mostly concerned with controlling the way this information travels. And then of course, this information needs to travel through something. Is it traveling through a wired media or is it traveling through a wireless media? This is when we begin to talk about the physical and the data link layer. So these are what has helped to classify the devices you find in network applications. So the same thing applies to smartphone. When we're talking about integrating technology system into smart building, you also need to have a classification system. How do you classify these various devices? Is the device a physical layer device, is it an application level device, and whatnot? So those are the 3 major layers I like to reference, which is the application level, the network, and the physical. So having talked about that, the next foundational framework I like to reference is the communication protocol. So the communication protocols is what I like to refer as the brain of the network. Something has to decide how this information is being encoded and decoded. Something has to decide how error is being detected. Something has to decide the format for these signals and whatnot. This is where communication protocols come in. So this is like the brain of the entire interconnection you find in a smartphone. And there are 2 major protocols I normally like to reference when I'm talking about smart building technology. Of course, there are so many protocols in the industry. Some of them are proprietary, some of them are vendor specific, some of them are open source per se. But then there are 2 major protocols I like to reference. The first one is what I like to call what is called the Ethernet protocol, and the second one is what is called the Internet protocol. So we're talking about the Ethernet protocol. The Ethernet protocol, otherwise referred to as the local area network, makes use of the first 2 layers of the OSI reference model, the physical layer and the data link layer. What this actually means is that most of the time when you're interconnecting devices within the confines of the home and you don't really need an internet for those devices to communicate with each other, they are now making use of the Ethernet protocol. So this is what you find most of the time in when we're talking about local area network. We are just connecting devices through a network switch without necessarily needing the internet. That is Ethernet protocol. But then when you begin to go beyond the confines of the home and you now begin to interact with devices that are beyond the building, you are communicating with internet enabled devices outside of the building. Maybe you have a facility management company that is managing that one. This is where the internet protocol comes into play. Of course, this is what has brought about the World Wide Web evolution we find in recent times. Today, we live in a very connected world and everybody is communicating through the internet. So what has made this possible is the IP, which is the internet protocol. So these are the 2 major protocols. So basically, when you're talking about communication within the building, you're using the Ethernet protocol. When you're talking about communication beyond the smart home, you're talking about the internet protocol. And then beyond that also is what is known as the database. So there are so many technology systems that we also see in this presentation. And each of these technology systems, for example, the access control system, or the security system like the IP surveillance system, or even a smart lighting system. Most of these various technology systems you find in a smart home are operating with data, and each of them have a database. But when we talk about interoperable database, what this actually means is that each of these databases should be able to query each other and extract information. For example, the smart lighting system might need to get information about the occupancy state of spaces, or it might need to query the HVAC system to find out the temperature level of a particular space to adjust the lighting or whatnot. So these various technology systems need to be able to query each other, and that is where the interoperable database comes into play. There are so many database languages today in the industry that make this possible. There are three important ones. The first one is what is known as the structured query language, which is the SQL. And the second one is the ODBC, which stands for Open Database Connectivity, which is more or less an add-on to the SQL. And you also have what is called the Extensible Markup Language. This one is mostly utilized when you're handing over your BIM data to the facility manager. So some of these are database languages is what has made it possible for different technology systems to query each other and extract information. So these first three foundational references are the OSI reference model, the computer protocol, and the interoperable database has more to do with the IT side of the smart home. And then the last two, which is the integrated project delivery and the people-centric buildings, has more to do with the building and the way people communicate with it. So we're talking about integrated project delivery. We're talking about leveraging using information modeling and a very collaborative approach to delivering these buildings, unlike what we find in our industry today. When we compare our industry with other industries, we find out that they've been able to create what is called a holistic value chain that makes it possible for all the parties on a project to come together to much more deliver the project more in a very collaborative way. This is where the integrated project is. As we go down into this presentation, we'll talk more about all this. And also, when we're talking about people-centric buildings, remember from the definition, we'll talk about what smart building technology is. We mentioned that the end goal is to optimize the growth and objectives of the built environment. So the bottom line of integrating technology systems into buildings is to make the lifestyle of the end users much more, much more better, to improve their lifestyle and to also make the environment much more sustainable. So the bottom line of integrating technology systems in buildings is to make the buildings more people-centric. And this is where we are talking about how to make buildings much more user-friendly today. So these are the 5 major framework or references that you must talk about when talking about smart building integrations in buildings. So it's very important that you get this in mind. So having laid down the foundational framework, what then are the various technology systems you find in a smart home? So to do that, there are so many technology systems you find in smart home today, but I've been able to categorize this into 7 major classes or 7 major classifications. And then the first one here is what is known as the energy or the comfort system. So here we're talking about the systems that are responsible for the energy consumption of the building and also the indoor user comfort. So talking about this system, I'm referring to such technology systems as the HVAC system, or the smart lighting system, or the electric power management system known as the EPMS. So the HVAC system, we're talking about such things as the heavy devices you find in the building, the chillers, the dampers, the VAV, of course, the drill and whatnot. So these are the devices that come together to ensure that the building consumes less energy, and also help to condition every space in the building to ensure that the user comfort is optimized. And then, of course, have the smart lighting system that also helps to improve the visual experience in every space in the building. Of course, this sometimes I have to complement the daylighting and also ensure that every space in the building have the right lighting or illumination level depending on the activity that's ongoing. This also sometimes are programmed to automatically adjust. For example, when you are in a reading mode, the lighting might automatically adjust to meet your requirements. When you are sleeping, the lights might go off and whatnot. So that is where the smart lighting system comes in. Also have what is called the electric power management system. So under here, you have such things as making use of smart power strips to turn off devices when they are not in use, or making use of power over Ethernet to power a lot of devices in our homes today. So all these things help to ensure that energy consumption of buildings are optimal and also as minimal as possible. And the next set of system I have to talk about is the entertainment system. So this is probably one of the oldest systems you find in smart homes, and this has to do with such systems as audio distributions, high fidelity audio distribution in building, or high definition video or video distribution in buildings today, or even such things as the home cinema or the media room or the hi-fi audio and so many other entertainment systems, even such things as virtual reality or gaming solutions you find in smart buildings today. All these things are solutions that help to make the living experience of the end users much more entertaining and whatnot. So these are very entertainment systems. There are so many of them, and this is probably the most user-friendly of all the technology systems, or sometimes I refer to as the user interface. And then, of course, you have the security system. So this, when talking about security system, you are referring to two major things. One is the physical security of the buildings, and the second one is the cyber security of buildings. So we're talking about physical security, you're referring to such systems as the IP surveillance system or the notification system as well. And you're also talking about such system as access control system. So talking about access control system, for example, this helps to control movement into and out of the building. For example, every end user or every occupant in the building might have his biometric details integrated into the access control system. And before the person can access the building, the person probably have to put in a fingerprint or maybe the iris scanner, the person's eye can be scanned and whatnot. Or it could even be a voice command just to a voice verification system to make sure that it's the right person that actually enters the building and whatnot. So access control system helps to control movement to ensure that there's no intrusion into the building, physical intrusion. And then, of course, you have the IP surveillance and also notification system. So IP surveillance makes use of cameras, IP surveillance cameras, or even lenses that can be distributed across the building to monitor every nook and cranny of the building. So irrespective of someone is in the building or not, this also helps to monitor every corner of the building. And if there's any form of intrusion, this can easily integrate with the personal digital assistance of the homeowners or the occupants. For example, if there's an intrusion, you could notify through your smartphone, whatever you have integrated the solution into, or the mobile app or whatnot. So all these security, these first two has to do with the physical security. And then, of course, you have the cyber security, which is even of more concern in recent times as everything is going digital. So talking about cyber security, you make use of such things as the firewall, which sometimes can be an added functionality of the router that are found in the smartphone. So with the use of such things as firewall, you can be able to ensure that there are no cyber intrusion, or there are no cyber criminal issues that affect the smartphone. So there are so many firewall and technology in place. They have such things as port forwarding or packet filtering and whatnot. And so this technology has also ensured that every traffic that is going in or coming out of the building is properly monitored and ensure that there are no cyber security threats on the smartphone. And then, of course, we have the communication system. So communication is a very important need of every human being. So in the smartphone as well, there are so many systems that can be found that helps to enhance this communication of the end users. One of those systems is what I refer to as the home messenger. I mean, imagine your iPhone today, you have your iMessage on your iPhone that helps you to communicate with other members of your family and whatnot. So you can also have what is called the home messenger, which could be a digital screen on the wall that have more or less a digital signage system that can easily communicate and perhaps share information and files with other members of the family. Then, of course, more common is the IP telephone system, for example, whereby you can easily communicate through IP telephones in the building today. And because these devices are IP enabled, they can also host other features or functionalities even beyond making calls. For example, you can have applications that are installed for playing games right on your IP telephone. And then beyond that, even in recent times, you are beginning to talk about working remotely. So you also can have your teleconference system as part of your communication system that is found in a smartphone. So through the use of this teleconference system, you can even host virtual meetings right from your home. You can have a space in your home that is dedicated for hosting meetings or even coordinating your business activities. So you can just have a simple setup for audio and video, and of course, integrate it with the teleconferencing solution, and then you can have your communication, which is most time tailored more towards business communications. Then, of course, the next set of system you also have is the management and the utility system. So this set of systems are what brings together the various technology systems you find in a building. So under this category of systems, you begin to find such systems as the building management system, the facility management system, and also the healthcare system. So talking about the building management system, for example, the building management system caters more towards the operational functions of a smartphone, which is most of the time uses the local area network. So for example, you might have a unified dashboard in your BMS that every single technology system in the building is a module on that unified dashboard. For example, you might have your smart lighting system as a module in your BMS. You might have your access control system as a module in your BMS. You might have your IP telephone system as a module in your BMS. And at the end of the day, this offers a unified dashboard through which you monitor every single technology system. So this actually brings all of them together and on a unified dashboard, and it's very easy to see the operational activities of the smartphone. Then contrasting this with the facility management system. Facility management system, on the other hand, has to do with remote management of the smartphone. Most of the time, this is carried out by dedicated facility management company. So this, while the BMS caters more towards operational functions, the FMS caters more towards enterprise functions, such things as parts replacement, service orders management, work orders management, and whatnot. So these are most of the time done through such things as predictive maintenance, or even a maintenance contract signed between the homeowners and the smart and the asset management company. So these ones are more tailored more towards enterprise activities like replacing parts of the building when there's faults, and services and servicing of the building parts. So all those things are what you find under the FMS. And of course, you have the healthcare system as well. The healthcare system, health is also a primary function of a primary need of every homeowner occupant today. So imagine integrating your BMS or whatever you use as a centralized dashboard with your maybe your wearables and smart gadgets. For example, you might have a smartwatch that monitors your walking distance, or you might have your smartphone monitor your sleeping pattern and your day-to-day activities. And all these things can help to using artificial intelligence can also help to inform you on better ways to make healthier choices and live a healthier lifestyle. So all these are systems you find under the management and utility systems. And then of course the next set of systems is the lifestyle system. I call them lifestyle systems because this basically enhances the lifestyle of the homeowners or the end users. So under here, you begin to see such systems as social media. So imagine today we are basically in the era of social media, whereby we have so many social media platforms like Facebook, Instagram, Twitter, LinkedIn, Pinterest, and so many of them. So how about having a centralized one social ID that can bring together all these activities? I mean, some of these things might not be too much in existence, but these are possibilities whereby you can integrate all your social activities into your social ID. And with that, even the smartphone can actually get to understand your lifestyle, and with that, it can adapt over time and help to improve the overall experience of the end user. Then, of course, you have such systems as the wearables and smart gadgets. I mean, imagine the comfort of watching games through your VR glasses or issuing voice commands through a voice assistant and whatnot. So all these are things that help to improve the overall lifestyle of the end users. And of course, talking about that, you also have the home assistant. You can issue command to the home using such things as Apple Siri or Amazon Alexa and whatnot. So these are basically technology systems that help to improve the overall lifestyle. I mean, today we are more or less a Gen Z or Gen Z age, whereby we are a very trendy generation that likes to explore a lot of data solutions and trends. So these are solutions that can actually help to enhance the lifestyle of the end users. And then, of course, the last set of solutions we have here is, or last set of systems we have here is what I call the control. We're talking about control system. We are now looking at how to control these buildings. You know, when you look at the industry today, like I mentioned earlier, I've worked in the home automation industry. You see that there are two major parties that control buildings today. On one end, you have the custom integration industry. Here, you begin to find such control systems as Control 4 or Question. While on the other end, you also find control systems coming from the tech giants like Google, Apple, Facebook, Amazon, and the likes. You have the Apple Smart Home System, or the Amazon HomeKit, or the Google Home, and whatnot. So all these are very technologies. All these are very control systems that helps to control smart homes today. But then we look at these two, the custom integrations controls, and the ones coming from the GAFA conglomerate, Google, Apple, Facebook, and Amazon. You realize that these things are still more of an afterthought. You know, when you look at the historic background we gave earlier, you realize that this whole thing started as an afterthought. When a building has been designed, you now begin to impose control on it. So this is not what we find in other industries. I mean, when you look at the smartphone today, you realize that it's a very good combination of both the hardware and the software. The same thing with the vehicles that are coming out today. Imagine a Tesla vehicle that's just an electric gadget that is properly monitored remotely. So when talking about controlling smart buildings, you realize that for us to actually get to that level, we also need to make use of what is called the operating system. I mean, it sounds quite a bit odd, but that is what can enable to unify both the technology systems and also the hardware components of a smartphone. Leveraging the software and operating system can better control our smartphone. Of course, we'll talk more about this and we'll get to the innovations of a smartphone. So having talked about that, the next thing we want to talk about is the aesthetic representation of smartphones. So back in school, as an architect, we learned so many architectural movements in history. For example, we learned the Egyptian architecture, the Greek architecture, the Roman architecture, the Byzantine architecture, Gothic, Baroque and Rococo, and so many other architecture, Renaissance architecture and whatnot. But then even in more recent time, I also came across the modern architecture, the postmodern architecture, and whatnot. Even in this part of the world, we also have our own architecture, vernacular architecture, traditional architecture. So these are so many architectural movements that have taken place over time. So from an architectural perspective, I now tend to ask, do you think that smart homes or smart buildings also have their own architectural movement? So of course, I coined this phrase to define my own understanding or my own what I perceive as the movement of smart buildings, and I coined this orthodigital as a combination of two words, orthogonal and digital. So on one hand, the orthogonal is talking about the a play on modernism, because when you look at postmodern architecture, a play on postmodernism. Rather, when you look at the postmodern architecture, you see that what postmodern architecture did is that it borrowed some of the features of the modern movement, and then it discarded some of them and made them, because modern architecture is more of a rigid architecture, where you're talking about making use of free flowing plans, simple forms, making use of row windows, roof gardens, pilotis, and so many of the very defined and rigid things. But when it comes to postmodernism, we now had to discuss some of those, like making use of roof garden or pilotis and whatnot. So when you look at smart buildings today, to realize that most of the time they borrow these simplistic features of the modern architecture. So that is where the orthogonal comes into play. And then on the other side, you're talking about digital. So this most of the time refers now to the aesthetics or the finishes of this smart building. So when you look at a smart building, at least looking at it from exterior to give that feel that this is actually a smart building, just by the way it's being finished. For example, finishing building with the use of black tint or graffiti as spray finish and whatnot. These are ways to make building actually look digital. But this does not affect the functionality of building or even becomes a guarantee that the building is smart. But of course, this is just a way to make a building appear smart. And they also go beyond that to also the user experience. When I eventually walk into the smart building, you begin to see such things as touchscreen, you begin to see such things as home assistant or voice assistant, and so many of these digital and trendy stuff. These are digital ways to make building actually look smart. So you see that we look at it, you see that the orthogonal has more to do with the functionality of the building, while the digital has more to do with the structure and the aesthetics of the building. So to me, this is a way of looking at smart buildings from a very architectural perspective, which is what I refer to as the system of aesthetic presentations for smart home. So having laid down all this background now, we now want to look at some very unique innovations that are possible leveraging smart building technology. So I've been able to break this down into 4 major innovations. Each some of them might come as a position, like I mentioned earlier, to the norm to find out industry today. The first one I have here is what I call the unified IT infrastructure. So for me to even describe this, imagine you walking into a typical home today. When you walk into a home today, you realize that there are so many types of faceplate to find in a home. You find out that for you to connect your DSTV, sometimes you might have your RGC faceplate. For you to connect your IP telephone, you might have your RJ45 faceplate. For you to connect your laptop, for example, you have your power faceplate. There are so many types of faceplate you find in smart building today. And this is just simply because of the distributed nature of our industry. So how about the possibility of actually having a unified faceplate in building? That sounds a bit odd, but for you to actually think about that, let me also look at it from another way. When you look at technology systems and integrations in smart buildings today, you realize that everything is migrating towards the internet protocol. For example, the audio distribution in smart buildings today is moving away from the metric distribution to the IP-based distribution, which is known as the audio IP. The same thing with the video. Video is moving away from the HDMI and also the metric distribution towards the video over IP. The same thing with power. Today, we are talking about power over Ethernet, whereby power is being transmitted through data cables. So if all the technology systems and the signals are now data, that means they can also run through the same cable type, which is the Ethernet cable, which is the data cable, or the CAT cabling system. You have your CAT6, CAT7, CAT8, and the like. So if all the data today are now, if all the signals today are now data, binary data, that means they can all run through the same signal type. So this is where you begin to imagine a possibility of having a unified cabling infrastructure or unified IP infrastructure in smart building. What this means is that at the end of the day, what you might end up doing is to differentiate these different signals with different colors and also make sure that they are not crisscrossing and bringing about something as electromagnetic interference. But it's actually possible for you to have a unified IT infrastructure for smart buildings, because that is a way to actually ensure that all the technology systems are much more uniform and much more collaboratively integrated into smart buildings. And then, of course, the second innovation I want to talk about is the concept of unified control and management. So talking about unified control, earlier I was talking about the way we control buildings today, and I mentioned the control systems from the custom integrations industry like the Control 4 and the Question solutions. Or you also have control systems coming from the GAPA conglomerate, Google, Apple, Facebook, Amazon, and the likes. So we now talk about the idea of controlling buildings or integrating the technology system through a unified control system. And when you look at online industry, you see that the way this has been done is through what is called the operating system. For example, your smartphones today have an operating system, your PCs today have an operating system, be it iOS, be it Windows, and whatnot. So what this has been able to do is to be able to unify both the hardware and the software components of these devices. So in a smartphone, it's also possible for you to control the various technology system. And of course, this is not so abstract because there have been attempts over time. I've had such projects as the BACnet, Loanworks, Modbooks, and even in more recent times, as a research done by Dr. Agatha Stevens back in Berkeley University in California, where he thought about the concept of BOSS, which is the Building Operating System Services. So these are some attempts over time that have tried to bring about a unified way of controlling these various technology systems you find in a smartphone. And even more recently, there has been an innovation from Siemens as a company known as MindSphere. So MindSphere is an open source operating system that enables people to also hop on it and build on it and create a much more open platform for controlling buildings. So these are some unified attempts that have been made over time to control buildings, unlike the ad hoc control that we find today in the industry. So at the end of the day, you see that what this unified control does is that it places most of these technology systems on a lower layer, and this is what is called the SCADA architecture, supervisory control, and data acquisition to control these technologies. And this is just one of the ways that the technology system can be uniformly controlled. And this brings about a much more unified approach towards the smart building. And then, of course, the third innovation I have here is the sustainable and alternative power. So today you realize that across the globe, we are relied mostly on the power grid coming from the government or whatever private or public company that supplies power across the city. But when you look at it, you realize that it's still possible for us to provide our own power making use of such things as solar panels or inverters and whatnot. And the interesting thing about these things is that because they are within the confines of the home, it's possible to actually supply DC to these homes. And this DC, because the shallow voltage can also be transmitted through the uniform cabling information we talked about the last time. So making use of such things as power over Ethernet, we realize that it's actually possible to make the power consumption of smart homes much more reduced. So these are some sustainable and alternative way of managing and providing power to smart homes. And then we see that this actually makes managing technology even more sustainable and consumes less energy. Of course, these are some innovations that challenges what you find today in the industry, but these are some things that are possible, leveraging smart building technology and other technologies that are already available in the market today. And then, of course, the last but not the least is the concept of remote facility management. So I mentioned earlier that when I talk about the facility management system, I mentioned about managing the smart homes remotely through a facility management company. So what this does is that it relies on the building management system that is within the confines of the building that is charged with the operational management on the smart home. And then it gets information from this building management system to carry out such things as predictive maintenance and also such things as service orders and whatnot. So what this does is that, imagine when you buy an iPhone today, what you're actually buying is just a piece of hardware. All the software components of an iPhone can be updated remotely. I mean, virtually every 3 months, Apple releases an update of their software or their firmware and whatnot. So if these smartphones are managed remotely, you realize that it's actually possible to also better manage facilities because every component of the smartphone will be easily updated and upgraded as small technology trends come into the scene. What this also means is that when you're delivering smart buildings, you're not just delivering products, you're actually delivering services to the end users because over time, these services will keep improving and improving on the smartphones to make the lifestyle of the end users even much more experiential. So these are some very unique innovations that are possible leveraging smart building technology, and I hope that they all come as so much of a distant thing because some of them are already available today. So having looked at these having looked at the smart home as a component or as a gadget, we now want to start looking at the delivery process of the smart home. And this is where building information modeling comes into play. So in the flyer of this webinar, I mentioned that BIM alone cannot solve the problems of the construction industry, because when you look at the industry today, BIM has become a buzzword, and so many people associated with anything that can solve our problems in the industry today is more or less referred to as business information money. So anything digital transformation that's upcoming today. But then when you look at this, you see that BIM is just a delivery vehicle, and it makes sure what is called an integrated delivery approach. I mean, when you look at our industry today, there are so many delivery of contract methods that we find today. We have such methods as the design bid build, or the design build, and so many other contracting methods. But one thing is common with all these contracting methods is the fact that they are not very unified and holistic. So, but using the integrated project delivery approach, all the stakeholders on the project are assembled early enough into the project, and it harnesses their insights to maximize the benefits of that project to the client and the end user. So for you to actually properly deploy BIM on the project, you need to carry out what is called the BIM execution plan at the early stage of the project. So basically, as the name implies, this has to do with planning the execution of BIM on the project. So this has been able to break down into 5 major steps. The first step is to assemble a unified team right from the project inception. Unlike the other contract method that I mentioned earlier, like the design bid build, you see that when a project wants to start, the typical thing is that the client looks for an architect that is affordable or design a house for you. And then with those initial designs, they begin to put it out for bid, and then the main contractor begin to come in, and then down the line, the main contractor begin to assemble the subcontractors, and then you need other professionals or specialists, consultants, and they begin to come in. So all these parties are not in the picture from the inception of that project, and then it makes communication and coordination of that project much more disjointed. And this is one of the major reasons why our industry today is very inefficient and very wasteful. But then we're talking about the execution plan or deploying BIM on the project. At the inception of that project, we need to assemble a unified team. And that unified team is what we now carry out the execution plan, which is the subsequent steps we find on this slide. So the first step here is to identify the project goals and use them to what is called BIM uses. So first of all, the project goals have to come from the slide, what is known as the employer's information requirements, or EIR for short. And then through these employer's information requirements, we now begin to scan through the various BIM uses. So according to Pennsylvania State University Execution Planning Guide, there are 25 million BIM uses in the market today. So typically, when you're at this stage of your BIM execution plan, you need to scan through these 25 major BIM uses and identify which ones suits the goals of that project that have been stated by the client in the employer's information requirement. So at the end of the day, you might end up with just 5 BIM uses out of the 25. For example, you might choose that, okay, for this project, we want to be able to carry out quantification from the BIM model, or at the end of this project, we need a record model that can use to better manage facilities, or want to be able to author these BIM model using so and so software and whatnot, or want to be able to use that BIM model to sequence the project execution, which is known as the 4th dimension of BIM and whatnot. So these are some BIM uses that I'm able to extract. So what this also means is that BIM execution planning is specific to every project. So ideally at the beginning of every project, you need to come together and carry out the same steps. So the first one is to identify the project goals and then reduce them to BIM uses. And then once we reduce all these project goals to BIM uses, you now need to map these BIM uses. So basically, there are 2 different types of process map. You have what is called the level 1 process map, and you have what is called the level 2 process map. The 1 process map basically shows an overview of the project and shows how these various BIM uses have been selected in the previous step relate to each other. For example, it will show you how your design authoring relates with your quantification, and how it also relates with your project timelining, and how all these things eventually builds up to recognition. So when you look at the level 1 process map, it just serves as an overview of the entire project. And then we're talking about level 2 process map. This now has to do with each of the BIM uses, how they will deliver. So which people are responsible for delivering this BIM use and how would they relate to each other. So this is more or less an internal coordination of the various team members. It will also show you how their activities relate to each other. So this is now peculiar to every BIM use. So what this means is that in a project, you only have one process map, but then you can have as many level 2 process map as there are BIM uses on that project. So once you've been able to create your process maps, you now begin to extract what is called an information exchanges from them. And this is very reduced to what is called an IE worksheet or information exchange worksheet. This is basically an Excel sheet that shows a work breakdown, a breakdown structure of the smart room, and then it shows you how each of these BIM uses, how information is being exchanged as the project progresses. So typically, this information exchanges is mostly extracted from the 1 process map. So for each of those BIM uses, you have the information that is coming out from each of them, and this information most of the time is coming out as documents and whatnot. So you now begin to extract that information that is being exchanged as the project lifecycle progresses into a breakdown, or which is an Excel sheet. So from here, you also begin to specify something like your LOD or level of information need, and also the software that will be needed to deliver this being used, so many other details. So this is, to me, is the most important aspect of this implementation planning process, because this is what the BIM manager will eventually use to track the project as it progresses. Because from this information exchange worksheet, the BIM manager will be able to see who and who should provide what information at every stage into the project, and at what level of detail that information is needed, and all these necessary details. So this is a document that is used as the project progresses through design, construction, and even the end of the handover stage of the project. So when you look at this, you see that information exchange is a dynamic document, is a live document, and that is what the BIM manager uses. And one thing that is also very interesting about this is because this whole activity is done in a very collaborative manner. All those information exchanges that have been identified on the worksheet is more or less contractually binding, because all the parties came together to actually agree that they will deliver this transfer information at that level of detail at every point in time into the project. So once they have the worksheet, one last thing I need to do is to identify the support infrastructure to make the implementation plan, the implementation of the project a success. For example, there are three major aspects of this support infrastructure. One is the hardware that's needed to make the project goals possible, and then the next one is the software, and then also have your model referencing and information. We're talking about software, for example. We are now beginning to define what software we needed to achieve each of these various BIM uses. For example, what software we use for design authoring? Is it going to be Autodesk Revit, or is it going to be ArchiCAD for Graphisoft? Is it going to be, what are you going to be using for your analysis, structural analysis, for example? Is it going to be robot structure? Is it going to be Bentley? Is it going to come from Bentley? What are you going to be using for your quantification? Is it going to be Navisworks Managed, or is it going to be Costlex? So you need to define all these software, and not just the software. You also need to define the version of the software. For example, if for example, if you are using Revit on a project, one party cannot be working on 2020 version, another party is working on 2018 version, because it will make information exchange impossible. So all these things need to be defined as early as possible into the project, and then also you need to define the hardware. For example, if you are carrying out CGI or visualization on the project, for example, you can't be working with no specification workstations on laptop. So you need to make sure that the hardware you have the right specifications to be able to achieve the use. And then when you're talking about the model references or information, you're not talking about the various components or the various families, the BIM standards when they are used to carry out your model, to ensure that everybody on the same page, and information exchange between the various parties are properly carried out. So these are various aspects of the support infrastructure that you find is nothing really. So at the end of the day, when you finish carrying out this implementation plan, you now have what is called the implementation plan as a document. And this has about 14 different sections according to the implementation plan guideline that will be developed by the Pennsylvania State University. And this document is what is now going to lead to other stages of the project. So this is a very important step of a smartphone delivery, leveraging building information modeling. And then, of course, once you are done with the planning, you now move to the design coordination phase. Today, according to the Building Smart Alliance, there are 4 major levels of BIM in the industry, starting from level 0 to level 3. Level 0 featuring little or no collaboration at all, while level 3 featuring the highest level amount of collaboration that is on the project. So today you find so many countries mandating BIM, and mostly they are always at level 2. But for example, in the UK, they've mandated that every publicly funded project must operate at least at BIM level 2, or every building that meets a certain number of floors must operate at BIM level 2. Other countries too are mandating it in their different ways and whatnot. And most of the time, that these are doing level 2. But then from experience, when working at doing level 2, what this entails is that you're sending 3D information, and of course, making use of software as IFC, ensuring that information is easily exchanged between various parties. But also the argument here is that because these models that they're not in the same location, it's very hard to track things over time. So that is where the concept of being level 3, although not fully defined in industry today, that is where the concept comes into play, whereby you have what is called the common data environment that accommodates your unified BIM model, so that every stakeholder on the project have a controlled access to this unified BIM model. So in other words, everybody on the project are co-creating the unified BIM model that sits on a common data environment. And this is where the whole idea of working on the cloud, or the whole cloud interface that design tools going to come into play. So what this means is that everyone on the project have access to up-to-date information at every point in time. And this doesn't stop at design coordination. It's the same thing when you get to field coordination and even at handover to the project. So what this is trying to talk about is that for you to properly deploy the benefits of smart building technology, every member of the project needs to come together through the integrated project delivery, and working with such things as a common data environment and a unified BIM model. Everyone collaboratively delivers this video. And this is far from what you find in the industry today. Today, you find out that when you're delivering projects, you find an architect or an architectural firm start with a design, and then a design they must have done in a 3D software, they will export it to 2D format, for example, and send to another party. The party will do their own. And through this disjointed approach to designing buildings, it becomes hard to manage the information. But when you're working through a unified platform or a common data environment, it becomes easier to manage information exchanges. So now we've talked about the planning, and we also talked about the design stage. The next one I want to look at is the value chain of a smart home delivery. So here we're now looking at the smart home delivery company, for example, because the focus of this application is on residential buildings, which is smart homes. Of course, we're talking about smart building technology, but our focus is on residential, which is just like a case in point. So we're talking about a smart home delivery company being able to break down the value chain into 5 major subsystems, which is founded on lean manufacturing principles borrowed from the automobile industry. So the first subsystem you find here is the planning subsystem, which caters more towards the planning stage or the BIM execution plan that we've talked about previously. And then the next subsystem here has to do with the design condition, which now has to do more with collaboratively design and delivering these buildings. And then the third subsystem has to do with the field coordination. So this has to do more with leveraging technology to make our field coordination much more efficient. For example, making use of such things as drone or laser scanners, or making use of mobile apps to communicate with people that are on the site and people that are not on the site. All these are technology or digital innovations that we find today that make it possible to minimize the waste and also save time and improve the efficiency of the way we design and deliver it today. So this basically has to do with leveraging such things as artificial intelligence and so many other emerging trends in the industry today to make our productivity and our efficiency on our site, project site, much more higher. And then, of course, the first subsystem we have here is the inventory subsystem. So here we are looking at a company that delivers smart homes, and we are talking about leveraging such things as lean principles to manage their stock. So here we are now looking at borrowing such concepts from the automobile industry, like the just-in-time approach, whereby using what is called a leveling system to ensure that you have minimal amount of stock in your inventory, and also using such things as the pooling system to minimize the stock you have in your inventory, and also using such things as the leveling system to ensure that you have some material in stock against emergency. So this is collectively referred as just in time because it helps to minimize wastage and also helps to ensure efficiency. And for you to do this, you also need to deploy a very organized value chain, meaning that even your supply chain is in tune and up to date with your activities as well. So if you look at such companies as Toyota, for example, you see that they've been able to unify both their internal and external parties. Same applies to Apple and so many other industries, other companies we find in other industries. But this is very, very unlike what we find in our industry. It's very hard for you to see both the supply chain and the designers and the end users, everybody working concurrently and in an up-to-date manner. So leveraging these are the inventory and the lean manufacturing principles, you find that the value chain can become much more holistic. And then, of course, we have the last subsystem here, which is the business management subsystem. So these are the name implied has to do with bringing together the business processes of a smart home delivery company. And like, for this to be effective or efficient, you need to bring together all these other various subsystems, the planning, the design, the field coordination, and inventory management into a unified subsystem. So when it comes to smart home delivery, for example, there's a very good solution out there called Co-Construct that actually helps to bring together the processes of rebuilding from all the way from the conceptual design stage to the handover and the operation stage. So, but then what they are saying is that every business management tool should be able to unify these various subsystems and make sure that everything is tied together into an integrated project delivery approach. And then business management also goes beyond just integrating the system. It also has to do with the human beings as well. So here you now start talking about the team setup and the branding and the innovative nature of the of the working environment. So how is the work environment, how is it the setup? Does it empower people to come up with innovative ideas? And how is the brand even perceived outside of the four walls of the company? So look at some companies today, like if you look at if you look at Tesla, for example, there's an impression that people have towards Tesla, simply with Apple or Mercedes or whatever company. So the brand perception, all these things has to do with business. So now, having talked about the value chain, we now want to start looking at the fabrication and the fabrication stage of these smart homes. So at this place or at this stage, one of the important concepts we want to look at is the idea of prefabrication. So prefabrication, as this name implies, has to do with fabricating most of the building components off-site in a conditioned environment. So ideally, at least 60% of the building components must have been manufactured off-site in a conditioned environment. So when you look at the industry today, there are 5 million levels of prefabrication, starting from what is called the componentized systems. When we're talking about the componentized level of prefabrication, you're talking about manufacturing the building components, in a component by component. For example, you manufacture the doors, the windows, and whatnot. So this is the componentized level of prefabrication. And then after that, you now have what is called the linear systems or the linear level of fabrication. So here you're not talking about manufacturing things in place, like your wall plane, your plane, your roof plane, and whatnot. So this is, to me, is the minimum level of fabrication that you must attain. We're talking about smart home delivery. And of course, arguably the most popular of them all is what the modular architecture or modular level of fabrication. So this is catered more towards high-rise buildings, where you're now prefabricating the building in modules. For example, you might fabricate a complete room and then you assemble it room by room by room by room and all that. So basically breaking down the building in modules. And we've seen some construction in recent times that are carried out in a very short period of time. For example, the hospital that was built in China within a few days at that time. So these are mostly carried out through the modular method of prefabrication or level of prefabrication. And then of course, after that, you have what is called the hybrid system. So this is mostly a combination of the previous two, the linear and the modular level of fabrication. So this, of course, is more flexible and also a recommended level of fabrication. And then, of course, the last but not the least is what is called the unitized code system. So this is the most cohesive and the most integrated level of these fabrication levels. So this has to do with assembling the entire building offsite and then bringing it to the site. This is also the concept that I brought about such things as mobile buildings today, whereby you can even move the building around from one location to the other. So for you to do this, you need to leverage very high technology in place, and of course, this is much more flexible. Despite all the level of fabrication, I also want to look at the advantages of working this way. Firstly, because you are working in a conditioned environment that is offsite, you are able to the entire workflow becomes more predictable, unlike when you are subject to site conditions. And then, of course, this helps to minimize the so that it will be able to withstand the climatic conditions on the site. So this is where the idea of prefabrication comes into play. So when you look at this, you see that prefabrication, it helps to minimize the amount of labor on the construction sites, and it also helps to minimize wastage, and also, and which is even much more important, is that it makes the entire process much more faster, and then at the end of the day, it contributes to the bottom line of the owner of that facility. So this is where we're looking at the entire industry getting to in a near future, whereby most of the building components are manufactured off site, and when it comes to the sites, you mostly carry out assembly. And of course, this is also made possible with such things as digital fabrication, making use of such things as CNC machines or 3D printers, and even making use of such technology as robotics and whatnot. All these things are what helps to make the fabrication and assembly of these smart homes much more efficient. And then, of course, after the building has been delivered, you now get to the management phase. So One of the interesting concepts today, of course, the entire importance of leveraging the building information modeling approach is that when it gets to the facility management stage, you now have much more rich information and data to better manage your facility. So this some people have referred to as the smart FM or BIM for FM. And then of course, this is built mostly on three major principles. The first one is that it's tailored towards the people that will be mentioning all this while, and then also brings about the concept of smart spaces. And they're also talking about the assets. So we're talking about people-centric buildings. We are talking about making sure that the entire technology system that are integrated into that building is tailored more towards the comfort of the end user. So it's not just integrating technology into buildings for technology's sake, but also ensuring that those technology systems are serving the end users and helping them to live a better life. And then of course, this is made possible through what is going to be at smart spaces. Some of the companies that have been doing a lot of work in this regard is the Siemens as a company. So they've been working around the whole idea of automating rooms and making rooms to become smart and adapting to the needs of the end users. And then, of course, when we're talking about assets, we're talking about the building entirely. So having a unified information about the building helps to better manage the assets. And most of these things are carried out through what is now known today as data training, which, of course, is still an emerging trend, or of course, it's been there for years, but it's gaining more traction in recent times. So the concept of digital training has to do with having a real-time communication between the BIM model that was generated during the design and the delivery of the building, and then the actual building. Of course, this is what we expect building information modeling to get to in the near future, whereby at the end of the delivery process, you have every single component of that building with accurate information and specifications. So every single component of the building have the right variety details, manufacturer details, and every single information that the facility manager for that facility will need to better manage the facility. And this BIM model is what is called the static data. And then you now have dynamic data that's coming from the building in real time. And this is carried out with use of sensors and other intelligent tracking solutions. So this helps to ensure that as the building is being operated, there's a real-time communication between the data train and actual building. And all these things help to bring about things like predictive maintenance, whereby the data train can easily track the building components and be able to predict that this place will be comfortable in the near future and whatnot. Also things like real-time diagnostics, carrying out services remotely, making it through the facility management solution. And then also things like condition monitoring and real-time information exchange and whatnot. So at the end of the day, that data train is just the most efficient tool to manage our facilities in the near future. So this is where we expect smart building technology to get to in the near future. And of course, all these things are built on four major technologies, which is big data, artificial intelligence, Internet of Things, and also cloud-based access. So what we've done so far is look at all the things we've discussed so far. Started by looking at smart buildings as components, and then we'll now begin to look at how to deliver these smart buildings. We started with the planning stage, and then we looked at the design stage, and then we looked at the entire value chain, and then looked at the pre-fabrication, and then also we looked at the maintenance stage of a smart building. So when this building has been delivered now, you might think that that is very ongoing. When you look at what is ongoing today, you realize that in our industry, they have this negligence towards embracing technology. What we do most of the time is that we wait for technology to mature from another industry before we begin to integrate it into our industry. But when you look at what is ongoing today, because from experience, like I said, I've been in the automation industry for quite a while. You see that the tech giants in the online industry, in the IT industry, are already eyeing our industry in a lot of ways. Today, as I mentioned earlier, there are so many control systems coming from Google, Apple, Facebook, Amazon, and the likes. And even these people already have enough data to track our needs and our lifestyle. Talking about social media today, only Google, only Facebook, for example, have Amazon, have Instagram, Facebook, WhatsApp, and whatnot. And Google, basically, everything you search on the internet is indexed by Google and whatnot. So these people already have enough information about us. And now, when we now combine this with our residential experience or our experience at home, there's no limit to what they can do with this. So when you're looking at our industry today, right, that the actual professionals in the industry today are averse to most of this technology and emerging trends that we're talking about. But then this negligence of our industry is actually what will pave way for the IT giants to actually infiltrate. And when they eventually infiltrate into our industry, we find out that it will be hard for us to compete with this people because they have much more resources than we have. They have much more capital at disposal, they have much more funding power and whatnot. So you see that there are multiple threats coming from this Google, Apple, Facebook, Amazon, and all these tech giants, Microsoft, and so many of them. So what this actually means is that we as professionals in the industry need to begin to embrace this technology and not just look at it as an add-on, but actually as an integral part of the design and building process. So if you refer back to our definition of smart building technology, you see that this actually has to start from the conceptual stage of a building all the way to the operations phase. And this is now, the bottom line of this is to improve the environment and also the end users of those facilities. So at the end of the day, that smart building technology is not just for luxury, it is mostly a utilitarian activity or purpose that it serves. So as regards that, I've been able to break down the creative values of smart building technology into 4 major advantages. The first is what I refer to efficient delivery processes. So of course, we'll be talking about smart building technology and we'll be talking about integrated project delivery as well. What this whole thing does is to unify the entire value chain, and then everybody is collaboratively designing and delivering buildings. This spans as far as the suppliers and the manufacturers, the clients, the end users, even the facility managers on the project. So when all these parties come together to properly plan and deliver projects, this brings about an efficient delivery process, and this helps to minimize the wastage we find our industry today, because it's been estimated that on every custom project there's as much as 30% of waste. Most of the activities that are carried out are even just a waste of time. So, but when you have a holistic value chain, this helps to bring about an efficient delivery process. And of course, when this is now leveraged to deliver this building, this also brings about reduced operational expenditure, because when we're talking about digital twin and managing these facilities, we realize that we have much more rich information to better manage facilities. And then leveraging the data that have been generated during design and delivery of this smart building, facility management becomes less expensive. The operational expenditure of the smart building becomes even less, because you have much more informed insights and data that helps you to make more predictive, carry out predictive maintenance and reduce the overall expenditure of building. Because today you also been estimated that as much as 60 to 90% of the life cycle cost of a building takes place during the operational stage of that building. So by leveraging these smart building technology approach, we realize that the overall expenditure of a building gets reduced, especially during the operational stage of that building. And then of course the next one we have here is optimal end user experience. So we were saying that the bottom line of integrated technology systems in building is to optimize the lifestyle of the end users. So through an inclusive and integrated project delivery, smart buildings should become people-centric, because these end users have been part of the design and delivery process, and then they are also making sure that the entire integrations is tailored more towards their use and comfort. So leveraging this smart building technology, ensure that the buildings we are building today become more user-friendly and people-centric. And then last but not least is the fact that this will also bring about increased security, because in the face of cybersecurity challenges today, an integrated approach to technology systems integration will offer robust security to end users. So if you look at the industry today, you realize that most of the way we integrate technology systems in buildings today is done in an ad hoc manner. For example, you go to the market today, you find an IP-enabled fridge, you purchase the fridge and bring it to your home and connect it to your network. The next day, you go to the market, you find a fancy bulb that is IP-enabled, and you purchase the bulb, you come home and connect it to your network. Next tomorrow, you go to the market, you find another component that is IP-enabled. So at the end of the day, this is what is known as Internet of Things. Everything is IP-enabled. But then, because there is no holistic planning of this, all these things become a loophole for cyber criminals to penetrate buildings. Because we've had a case of cyber criminals that are able to infiltrate a university through an IP-enabled printer, for example. So this is where leveraging a holistic approach to managing the security system will help to increase the security of this smart building. Because today, most of people are afraid of smart buildings because they are scared of cyber criminals. When we offer a very holistic approach towards integrating the technology systems, we bring about much more security. So having said all that, the next thing I want to look at is the possibility of taking this to the city level. Because of course, the same technology systems we deploy in our smartphones is what is also being deployed in cities. So today we're talking about such things as traffic monitoring, noise pollution, energy management, water management, smart lighting, and all that. You realize that when you actually leverage these smart buildings, you can generate rich insights from people, the city dwellers, and with that rich insights, you can even use it to make our cities even much more sustainable and smart. For example, there have been a lot of projects ongoing in Lagos, for example, in Nigeria, tailored towards the smart city concept. So we expect that in the near future in African cities, when all this smart building technology have been deployed and have a much more collaborative approach towards building buildings, you can leverage the same data and technology systems to improve the overall lifestyle and livelihood of people in the city. So of course, this presentation is tailored more towards residential buildings, but this is just to give you an idea of where this can actually take us to, which is the whole concept of sustainable and smart cities in the near future. So as some of you might have already known, for the past few days, we've been quite doing some campaign. Like I mentioned earlier, when I was introducing myself, I mentioned that I published a book last year titled The Essentials of Smart Building Technology, which is available on almost all the ebook stores you can take up today. So as of today, we launched the video version of that ebook. So basically, what we've done is that we converted the ebook to an online video course. So every single page on that book is a video clip. And then I want to share with you what the platform looks like, which we actually just launched today. So first of all, the link is courses.blazeinc.net/courses/SBT, which is smart building technology. So when you see this link, you see the courses. So everything we'll be talking about in this presentation is just a summary of what you find in the course. So when you look at this, you see that it's focused on smart homes, not just smart building technology, but smart homes, because it needs to be very specific. And then when you come to this page, if you click on this, you find more or less an general introduction of the course and offers how our industry is situated. Of course, the course is broken down into three major parts. In the first part, you have it talking about smart homes, and then in the second part, you have it talking about the smart delivery, which we've talked about in this presentation as well. And then in the third part, you have it talk about the smart innovation, which is basically bringing the smart home and the smart delivery together to offer some very unique solutions possible, leveraging smart building technology. So we started by looking at the context, which is African cities, and then in the last chapter, we now offered a business perspective to smart building delivery. So of course, this course is broken down into three parts, and then it's now made up of 12 chapters. So you look at this, you see that in this first chapter one, or this one, the first one here will have the welcome to the course, and then this is part one overview, and then you now have the chapter one. So chapter one is talking about smart home technology fundamental. This is basically a summary of the entire course, and then in the second chapter we're going to look at the foundational framework, which we talked about earlier. So here we go to dive into more detail on the OSI reference model, the physical layer, the communication protocol, database, smart building design, delivery management, and then if you also look at this, at the end of every chapter, you have the chapter lessons. So this chapter lesson that you see here is an extraction from the original ebook, which is available on your ebook platform today with the same title, Essentials of Smart Building Technology. So every chapter from that book has been extracted, meaning that by the time you finish running through this course, you would have gone through the entire ebook. And not just that, every chapter also comes with a quiz to test what you just learned. So by the time you finish going through chapter one, you go through a very small quiz to test what you learned. That way, it helps you solidify what you learn as well. And then that is it. In the third chapter, we'll talk about the basic components of the smart home, the fabric. So we're going to talk about the structural elements of the smart home. While in the next chapter, we'll talk about the technology components of the smart home, which we've looked at initially. We're talking about the energy and comfort system, entertainment system, security system, computer system, and all the technology systems we talked about earlier. And then in this chapter, we're going to look at some of these innovations we talked about. So here we're going to talk about the idea of a uniform infrastructure, DC electricity, operating system, data service, and so many other things. And then in the second part, that was where we now began to look at the delivery of a smart home, which we call the smart delivery. You see that in this chapter 6, we looked at the planning process, which is more or less the BIM execution planning. We looked at the team, the project goals, the process map, information exchange, support infrastructure, the game plan, facility program, and whatnot. And then in the next chapter, we'll now look at the design coordination. So we're going to look at the coordination checklist, specification documentation, BIM deliverables, civil experience design, BIM model, support documents, and so many other things. And then in the next chapter, we look at the value chain. So this is where we now began to look at the subsystems that we talked about earlier. So here we're going to see sources and the planning tools, design tools, field management tools, inventory tools, business management tools, and all the subsystems we talked about earlier. And here also talk about sources as common data environment and the key players we find in a smart home delivery. And then in the 9th chapter, that's when now began to look at the fabrication and prefabrication of the smart home. So here we're going to talk about the fabrication level, how to rationalize the BIM model, how to use the fabrication type, whether additive or subtractive, talk about the assembly line, supply chain, and whatnot. So many things we talk about. So this is tailored more towards the delivery of the smart home. And then in this last chapter of the second part, we now talk about the management of the smart home facility. So here we're going to talk about the facility handover, facility manager, video management system, facility management system, even end user support, and so many other things. So if you look at this, you find out some of them are already free preview. So what this means is that if you come here and click on free preview, you will only have access to all the ones here that have been listed as free preview. But it's only when you purchase the course, which is $75, that you'll be able to have access to every single video on this. So as you can see, this is well over 100 video clips that we well arranged and put together talking about smart building technology. And in the last part, that's where I'll be going to offer the solution. So we began by looking at Africa as a case in point. And we began to look at some of the challenges that are being faced in African cities today. So what is as existing constraints and the current realities. And after that, we're now began to look at some opportunities and the place of public-private partnership and even the place of technology and so many things. So this is the focus here is mostly on African cities, and then this is just a case, just to offer a contextual approach to it. And of course, in the last chapter, we now looked at the business of smart home delivery, which is offering a business perspective to the whole idea of delivering smart home. So this offers just offers an imaginary scenario whereby a client works into a smart home delivery company and others for smart home. We now began to trace all the activities that take place from the client discovery to design coordination to coordination with the partner, the fabrication, handover and maintenance. And then now we began to talk about the various smart home solutions and even offer the executive summary of the entire course. So this is quite a very loaded course. And then in the last part, now we began to look at even more resources, and then we talk about Blaze. So as you can see, this is a very comprehensive story of smart building technology, and of course, the instructor. And what's much more interesting is the fact that this course actually comes with a certificate of completion from BIM Africa. So when you completed this course, you'll be certified by BIM Africa as having everything it takes, at least having an overview of smart building technology and having a very holistic viewpoint to our industry. And then, of course, like we've seen earlier, each chapter comes with a quiz, and then each chapter also comes with a PDF version of everything. So these are some of the things we're already talking about, the course and the ebook as well. So this you can read it up on your own time and see what we already seen. So what the interesting part is that, and by the end of today, for the past 7 days, we've been offering a discount on this course, which is a 3.3% discount, meaning that you purchase this course today, and then when you get to check out, you type in pre-launch as a coupon, as a coupon code, you'll be offered a 3.3% discount. So instead of this $75, you get the course for $50. But this has been ongoing for the past 7 days, and it will actually expire in a few hours time. So you can still maximize the benefit of attending this webinar to get this discount. So having run through the course, we'll go back to our presentation. So beyond the course as well, we are also launching our online course platform today. Actually, this course is our maiden course on the platform, and this platform, as you can see here, is Blaze Online Academy. And at this point in time, we are actually welcoming content creators to also submit their content as courses on our platform. And of course, it will be a win-win situation for everybody. So if you know anyone that has content, or you are a content creator yourself, you can send your content or at least email us at info@blazeinc.net, and we will reply you in no distant time. So having talked about that, we thought to now conclude by offering a very brief overview of what we do at Blaze. So for the past couple of weeks, we've been organizing this series of online these are cloud webinar, and it's just part of our awareness and enlightenment on integrated and smart building technology. Like I mentioned previously, we've had presentations from Plannerly, from local geosystems, or have more interesting sessions lined up in the future. So this is just part of our awareness and enlightenment program. Then beyond that, we also offer training on innovative and digital tools and processes. So we offer training for companies on various BIM tools and even BIM processes. So basically, this has to do with training their staff to ensure that they become up to date with the whole emerging trends in our industry today. And then beyond that, we also offer BIM execution plans. So basically, we work with AECO, Architecture Engineering Construction and Operations firms, to produce functional BIM execution plans that are adapted to their workflows, spanning across the entire project lifecycle. So we've seen the importance of BIM execution planning. It's not possible to deploy BIM on a project without planning for it. So this is where the BIM execution plan process comes in, and we help firms to create functional BIM execution plans. Of course, we create templates that they can always adapt in a subsequent project, so that we don't have to always come whenever they get a project. And then beyond that, we also offer data solutions and integrations for smarter workflows for AECO firms. So what this means is that we can help firms to integrate the right tools and processes that will help them to maximize the benefits of digital transformations we see in our industry today. And they also offer integrated design services and consultants for AECO firms based on BIM and GIS. So this basically has to do with firms that may not have the time to begin to create some of these BIM models and all these processes. So they can actually outsource this to us, which we already done for a number of firms. We could outsource BIM, their BIM modeling process to us, and we can help them come up with very accurate BIM models that they can now utilize to begin to sequence their project or carry out cost estimates, application and whatnot. And then last but not least, we also build custom applications for architecture engineering and construction firms leveraging their BIM data. So this could be as simple as making use of Dynamo scripts, or in more advanced cases, this might have to do with creating things like Forge applications for them. But basically, we try to create bespoke solutions that are tailored towards their needs and their workflow. So this is just one of the services we offer at Blaze, and this webinar is just a way of us getting ourselves more enlightened and sharing knowledge and communicating and interacting with each other. And then at the beginning of this presentation, I also mentioned that I'm a founding advocate of BIM Africa. So currently, BIM Africa has launched a brand new initiative, which is the African BIM Report, which is meant to be released every year. So the first one is coming up this year, and we are part of the report is going to be a BIM survey that basically appraises the level of BIM implementation across Africa. So we just actually indulge you to kindly help fill that form. Just visit the link here, bimafrica.org/African BIM Reports, and help to fill the form. It shouldn't take more than 5 minutes at a time to fill the report, because this will help to give us an overview of the BIM implementation across Africa. Of course, the report is in many languages, both English and French. You can choose which one is best for you, and kindly fill the form. So at this juncture, we've come to the end of this presentation, and if you have any questions, we'll be glad to answer. You can either ask a question by raising your hand, and then we'll unmute your mic so you ask a question, or you can also type in your question into the chat box, and we'll be more than glad to answer your question. So once again, thank you very much for attending this webinar. I'll be opening up the floor for questions and answers.